Here we discuss about linear differential equations, and differential equations is said to be linear when the dependent variable and its derivatives appear only in the first degree. Equations are of the type dy by dx plus py equal to q, where this p and q, where p and q are functions of x or constants. In this case, the linear differential equation, general form of this linear differential equation is of the type dy by dx plus py equal to q, where the p and q are functions of x or constants. Now let us solve these equations. First, consider the part dy by dx plus py equal to 0. Now you can see that we write it as dy by dx equal to minus py. We are here separating the variable, that means we are separating the terms of the y and the terms of the x. You can see that the p is a function of x, so therefore we take this p and the term dx, and on the other side we take the term dy and y. So we can write it as dy divided by y equal to minus p into dx. You can see that the variables are now separated. Now let us integrate this. If we integrate this, we write it as integration of dy divided by y equal to integration of minus p into dx plus integrating constant. Friend, you can see that the integration of dy divided by y is equal to log y. So here we take the integration as a log of c. Then here we get log of c, log of y equal to minus integration of p into dx plus log of c. Transfer this term to this sides. Then we have log of y minus log of c equal to minus integration of p into dx, or log of y divided by c equal to minus integration of p into dx. Taking the exponential on both sides, we can have here y divided by c equal to e raised to minus integration of p into dx, or y equal to c into e raised to minus p into dx. This is the solution of the equation dy by dx plus py equal to 0. Or we write it as y into e raised to p into dx by taking this e raised to minus integration of p into dx to this side, or equal to c. Now let us differentiate this, differentiating with respective to x. What we get? This is first function, this is second function. Derivative of y is dy by dx into second function as it is e raised to p into dx plus first function as it is derivative of the second is e raised to p into dx, and derivative of this part by applying the chain rule. Derivative of this, integration and derivative get cancel, and we get p equal to this c equal to derivative of constant equal to 0. Now let us write it as a integration of p into dx common term. So, we have dy by dx plus p into y equal to 0. So, this shows that this integration of e raised to p into dx is an integrating factor. By multiplication of this term to the equation, we have get the solution of this equation, and therefore, this is an integrating factor. E raised to integration of p into dx is an integrating factor. So, let us multiply this equation dy by dx plus py equal to q by this integrating factor. You can see that if we multiply by using this factor, we get here e raised to integration of p into dx into dy by dx plus py equal to q into e raised to integration of p into dx. Okay. But this is what? This is the derivative, as we have seen, derivative of y into e raised to integration of p into dx. Just we have evaluated this. This is d by dx of q into e raised to integration of p into dx. Now, again integrating this equation, we get y into e raised to integration of p into dx equal to integration of q into e raised to integration of p into dx plus c, or y equal to e raised to minus integration of p into dx integration of q into e raised to integration of p into dx plus c. So, this is the solution of linear differential equation dy by dx plus py equal to 0. So, what we need? We need the values of p and q. So, let us put that values here. I am writing this solution of this equation here, so that we get the idea of that equation. What is the solution? Solution of this equation is e raised to minus integration of p into dx into e raised to integration of p into dx into q into dx plus c. This is the solution of this equation. Now, let us take examples so that your ideas will be cleared. We consider the equation x into dy by dx minus a into y equal to x plus 1. Now, let us divide, let us take this equation, write this equation in the form of dy by dx plus py equal to q. So, we get here dy by dx equal minus a divided by x into y equal to x plus 1 divided by x. By comparing this with this equation, here what we get? We get p equal to minus a divided by x and q equal to x plus 1 divided by x, or 1 plus 1 divided by x. Then integrating factor equal to, what is the integrating factor? E raised to integration of p into dx, that is integration of minus a divided by x into dx equal to e raised to minus a into integration of 1 by x, that is log of x, or equal to, we write this it as a log of x raised to minus a. Log and e are opposite, so they get cancelled, and we have 1 divided by x raised to a is the integrating factor. Then y is equal to, the solution of this equation is equal to e raised to integration of this minus term, or this is y into integration of p dx, okay, equal to integration of p dx into q into dx plus c. This is the solution. So, y into 1 divided by x by a equal to integration of 1 divided by x by a into this 1 divided by 1 plus x into dx plus c equal to integration of 1 divided by x raised to a plus 1 divided by x raised to a plus 1 into dx plus c equal to integration of this x raised to minus a plus 1 divided by minus a plus 1 plus here x raised to minus a minus 1 plus 1 x raised to minus a divided by minus a plus c. This is y into 1 divided by x raised to a, y equal to multiplying this by x raised to a, multiplying this x raised to a, we get here x minus a and x raised to a get cancel, x divided by 1 minus a minus 1 divided by a, x raised to minus a and x raised to plus a get cancel equal to c, and this is the solution of this equation, that is x into dy by dx minus ay equal to x plus a. Let us see one more example. Now consider again to clear the idea of this linear equations, we consider one more example. dy by dx plus y equal to e raised to minus x. So friend, here you can compare this, we get p equal to 1, q equal to e raised to minus x, integrating factor equal to e raised to integration of p into dx equal to e raised to integration of 1 into dx equal to e raised to integration of x, integration of dx is x. So your solution is y into e raised to integration of p into dx equal to integration of p into dx into q plus into dx plus c. Now just put the values only, y into integration of e raised to px e raised to x equal to integration of e raised to x into q e raised to minus x into dx plus c, or y into e raised to x, y into e raised to x equal to e raised to x and e raised to minus x, that is e raised to x minus x e raised to 0, e raised to 0 is 1. So integration of dx plus c equal to integration of dx is x plus c. Now transfer this to this side, so y equal to e raised to minus x into x plus c. This is the solution of this equation. So these are the simple example of this linear differential equation. Okay, now for practice we take one more example to clear the idea of this differential linear differential equation. See the example, cos square x into dy by dx plus y equal to tan into x. Now write the equation in the appropriate forms. Dividing by cos square x, we get dy by dx plus 1 divided by cos square x into y equal to 1 divided by cos square x into tan x. What is 1 divided by cos square x? We have dy by dx plus sec square x into y equal to sec square x into tan x. So let us compare. What is p? P equal to sec square x. What is q? Q equal to sec square x into tan x, right? So integrating factor equal to e raised to integration of p into dx equal to integration of sec square x into dx, integration of sec square x, that is this is equal to e raised to tan x. So we have derivative of tan is a sec square x, therefore integration of sec square x equal to e raised to tan x. Now what is solution? Y into e raised to integration of p dx equal to integration of e raised to p dx into q into dx plus c. Just put the values here. Y into integrating factor is what? E raised to tan x equal to e raised to tan x into sec square x into tan x into dx plus c. Now to solve this integration, we need to substitute integration. We put here tan of x equal to t, then tan x, derivative of tan x is sec square x into dx equal to dt. Therefore, this integration e raised to tan x into sec square x into tan x into dx, this is equal to integration of e raised to, here e raised to t into sec square x into dx, that is dt, but for this we write it as a t into dt. Now apply the product rule of the integration. You know LIATE, LIATE. T is exponential function and we have algebraic function. Okay, so this is algebraic function and this is exponential function. This is second function, this is first function. Okay, so first function into integration of second minus integration of second into derivative of first into dt equal to t into e raised to t minus e raised to t common, e raised to t into t minus 1. Now put the value of t. By substituting the value of t, let us put this value e raised to t. What is e raised to t? E raised to t, t is a tan x. So we have integration this y equal to y into e raised to tan x equal to e raised to tan x into tan x minus 1 plus c. Just multiply, transfer this term to this side, we get tan of x minus 1 plus c into e raised to minus tan x. So this is the solution of this differential equation. So friend, thank you for watching the video.